In example 7.1.4, we have proportions of 30%, 15%, 40%, and 15% that they had stocked the lake with. 5 years later, they take a sample of the fish and find that out of 500 fish, we have 117, 88, 223, and 72 of the various types. We want to know if the proportions of the types of fish in the lake have changed in the past 5 years. So our null hypothesis is that our proportions match what they stocked the lake at. So it would be a 0.3 was our 30% for the first category, 0.15, a 0.4, and a 0.15. And notice that those do add up to a total of 1, and we're dealing with k equal 4 categories here. Alternative, again, is just that at least one of the PIs or proportions in the null is incorrect. Okay, then we need to look at what our expected counts. Our expected counts are what the null says we would have. If we have 500 fish, and we're supposed to have 30% catfish under the null, our first expected count is 0.3 times 500, which is 150. Our second expected count is supposed to be 15%. So 15% of 500 would be 75 fish. If we have 40% bluegill, we would have 40% of 500, which is 200 fish. And then finally, our last category, 15% of 500 is again 75. And these will still add up to 500. We've just divvied them up according to these percentages that we are expecting if the null is true. Notice these are all greater than or equal to 5, and that is our only condition we need to check. So our test statistic is our observed count for the first group, 117, minus that we're expecting 150. Square that, divide by what we're expecting, 150. Then 88 for our second group, minus 75 squared over 75. Our next group had 223. We're expecting 200. Square that difference, divide by 200. And then finally, 72 minus 75 squared over 75. If you add these all up, you get 12.278. Degrees of freedom for the chi-square will be 3, because remember we do k minus 1 and k was 4. So we need to go to StatKey and get our p-value. So what we do is put in our degrees of freedom of 3. This will always be right-tailed test, and then put in our test stat, which was 12.278. And we get a p-value of 0.0065 if we look at that tail area. So this one, that is less than our significance level of 5%. So we will reject the null. And we would want to write out the rest of the conclusion, which would be that we have significant evidence that the population proportions of types of fish have changed in the past 5 years. We are rejecting that they stayed at those percentages, and we have evidence they've changed. When you find that you do have a difference, what you can do is get a feel for where the difference came from by looking at the counts that you have. What we can see is that we're expecting to have 150 catfish, but we only have 117, so those have dropped some. Whereas like the bluegill is the opposite. We were only expecting 200, but we had 223. So we can see sort of where the change happened when we find a significant difference.